All right, this is the last one I'm going to do for now. This is question 7 of the discriminant worksheet. And it says, find the range of values for the constant m so that this thing here has two distinct roots. So let's write it out first of all. So this is our question. Here is our equation. So I'm going to restate the equation because I'm going to just act a little bit on it here, m plus 2x. So I can see I've got a very clear coefficient of x squared, which is 1, a coefficient of x, which is m plus 2, and I've got a plus 3m. What I'm going to do is I'm going to subtract 2 from both sides here, leaving with 0, and the coefficient of our last thing is going to be a 3m minus 2. So I'm going to end up with an x squared plus m plus 2x plus 3m minus 2 is 0. And we're told the discriminant has to have two distinct roots. So therefore, we're looking at this has to be greater than 0. So we're going to have a, the value of a is going to be 1, the value of b is going to be m plus 2, and the value of c is going to be 3m minus 2. So we've got, this is rather nice, we've got a b squared minus 4ac is going to be greater than 0. B squared is going to be m plus 2 times m plus 2, because it's squared, minus 4 times a, which is 1, times c, which is 3m minus 2, which is greater than 0. All right, let's expand. So we've got m times m, which is m squared, m times 4, and we've got m, 2m, and another 2m, which is going to be plus 4m. Nice. Minus 4 times 3m minus 2, and I'm just going to expand this out here. So I'm going to m squared plus 4m plus 4. 4 3s are 12, so it's going to be minus 12m, and negative 4 times negative 2 is going to be plus 8 is greater than 0. So this is rather good, actually. I've got an m squared. I've got a 4m minus 12m, which is minus 8m. I've got a 4 plus 8, which is going to be plus 12. So let's just make sure I've got all that correct. It looks pretty good to me. All right, so I'm looking for factors of 12. Here we go. Factors of 12. The signs are going to be the same. And they're going to have to add or subtract to an 8. So the signs are both an m and an m. Signs are the same, both negative. And I'm looking for factors of 12, which is going to be, looks like a 2 and a 6 is going to work rather well here. Because 2 and 6 is 8. So I have a 2 and a 6. So I've got either, these are my critical values now. M is going to be equal to a 2, or m is going to be equal to a 6. Now, we've got to be a little bit careful here, but I would actually draw this out actually as a graph. Now, by the way, if that was less than 0, we've got to be very careful when we draw it as a graph, because it wouldn't actually be either or. It would be and if it was less than, but only in the graph. And I'll show you that another time. But for this one here, let's take a look. Here is my graph, and I've got my 2. Here's my 2. There's my 2 there, and my 6 is over here. There's my 6. The graph is going to look like this. I'm going to try and draw as best I can. It's going to go down here, going to head round, I'm going to head back up like this. Yeah, and that's what the graph's going to do. Now we know that this axis here, this is going to be my discriminant. This value here is going to be my m axis. And we want the values where the discriminant, the discriminant, that's meant to be a discriminant, it's not a very good triangle, is greater than 0. Well, here, the value is all in this sector here, the discriminant is greater than 0. Over here, they're less than 0. So over here, these are all less than 0. On this side here, all the values here are greater than 0. So in other words, the values between this and this, not all, notice, the values were between this and this, not all this or this and this are going to be less than 0. But the values on this side and this side, so it's going to be either this side or this side is my solution. So what we're looking for is stuff on this side and stuff on this side. And that's going to be my solution. Because why? Because everything on this side is greater than 0. The m values are greater. Look at, let's take one. What about the value here? This value here is greater than 0. What about try this value over here? This value here, that value there, that m value, that m value, that m value. All these m values are less than 0. Here, less than 0. But all the m values here. What about this m value here? Is that one? That's greater than 0. What about this one over here? That's going to be miles up here, and it's going to be greater than 0. So m values that are greater than 0 are going to fall on this side or this side. Okay, so the solution is going to have to be m is going to have to be greater. We'll start on this side. M is less than 2, or m is going to be greater than 6. Now notice, if the sign was the other way round, and we were looking for values that were less than, it wouldn't be 2 or 6. It would be between 2 and 6. So we just have to make sure that we make that distinction. All right, folks, the critical values, by the way, are still either that or that, but the range is this and this, or in this case, this or that. So just be aware of that. So there is our solution, and that is how I would write it. So m is less than 2, or m is greater than 6. Hope that makes sense.